Okay. All right. Welcome to acute training variables and resistance training. Basically, what we're talking about now is, what do you do in a single training session? Well, in some ways, it's like a recipe, um, and we're going to go through how to do that. The first thing you need to do is there's a number of steps. One, you got to perform a needs analysis, and then you have to go through several training variables like exercise selection, training frequency, exercise order, training load and repetitions, volume, rest period lengths. So let's talk about this. Step one is a needs analysis. And in a needs analysis, you have to, one, evaluate the sport, and two, evaluate or assess the athlete. Meaning, what's the athlete's training status, how would you test them, and what's their primary goal, right? So first we talk about evaluation of the sport, and that's where we talk about this movement analysis. So basically we're talking about what is the body and limb movement patterns and what's the muscular involvement. So, for example, if you have someone who is working on essentially a vertical jump, then what movement? That's a squatting type of movement. The muscles involved are the glutes, the hamstrings, the quads, etc., etc. But the physiological analysis is different. Basically, you're looking at, you know what muscles are involved, you know the pattern, the geometry of the movement, but how are they activated? Are they activated for maximal strength? Is it for maximal power? Or is it the athlete's goal to try and put on size? Or are they doing this movement over and over again, which would be more muscular endurance? So again, you need a movement analysis and a physiological analysis. So take a shot putter, for example. Okay, movement analysis, muscular involvements, most people say, oh, it's the triceps and chest. No, it's the full body. It's the full body. The geometry of the movement is that it's a 45-degree release point, right? And then how are the muscles involved in this? Well, remember, we have sort of an explosive strength deficit going on here. So they don't reach max force. And what matters is the rate that force is developed, which is power. We see a 0.81 correlation between quadriceps muscle activation and shot put performance. So we know the lower body has a large amount of movement in here. If we go to a physiological analysis, one movement that is the trademark of power is the vertical jump. And what we see here, we see a good relationship between the counter movement jump and performance with the shot put. But what's similar to a counter movement jump that's a maximal strength movement? So counter movement jump's a measure of power. What's a maximal strength movement that's similar to that? It'd be a squat, right? We see the relationship goes down to 0.35 with 1RM squat and performance in the shot put. So again, in order of importance, you need power, then strength, and then hypertrophy. So that's going to dictate how you optimize and how you periodize your training split. We then assess the athlete. In this case, the primary resistance training goal, basically, what is their goal? Again, it's not just the sport, because you could have an athlete, for example, who is a shot putter and where power is important, but they're weak. They're a relatively weak individual, in which case power burns in the flame of strength. So now strength becomes the most important variable. See what I'm saying? Okay, but you can have an athlete that's in a strength power sport, but they're very overweight and they're not very conditioned, so they can't do repeated bouts of force output at a good level, in which case their primary goal is going to be more hypertrophy conditioning, maybe some local muscle endurance. So the goals of the athlete have to interact with the goals of the sport. Once we do that, we go into our acute training variables, and we start with exercise selection. Now, we generally can move things into compound or multi-joint, or isolation or single joint movements. Okay, so compound movements, the advantages of those is you have greater sports specificity, greater gains in muscle mass, higher anabolic hormone response, greater transfer to the field. Isolation is good for bodybuilding and if you have injury rehab when multi-joint exercise is not possible. But if you're an athlete and you're healthy, you probably don't need to do isolation movements. Now, one of the most sport-specific things you can actually do is understanding the angles that's going on. So again, if you understand the geometry of the movement, if you have someone who's doing a vertical jump and you have someone skating, both require the quadriceps, the glutes, and the hamstrings. Okay, but skating is unilateral. So for them, what movement's going to be ideal? It's going to be lunges, and ideally something like walking lunges. Whereas for the jump, it's going to be a squatting movement. Okay, and then if there's two athletes that both do squatting movements, like a skier and a volleyball player, if you look at the geometry of the volleyball player, they usually only squat down and jump from parallel, whereas the actual skier jumps from a full squat. So the skier would do full squats, right? While the volleyball player might do parallel squats. And then if you have a shot putter, because the angle of release is 45, they're going to actually bench on a 45-degree angle. So that's things you need to understand. Now, the ultimate specificity is understanding that you can add resistance to the sport. You need to be careful with this and make sure that the resistance does not hamper the geometry of the movement. So if we take sprinting or running, for example, there are several different things we can use. If you run, you have to ask yourself, where's the resistance coming from? It's horizontally. You have wind resistance. Okay? So if you were to wear ankle weights, where's the resistance going? It's vertical. But if you were to do a parachute, right, that's horizontal. Now, if you were to do a sled, on the other hand, one of the disadvantages of that is it's more friction force and it gets you to lean forward too much and changes the geometry of the movement. If the resistance added to the sport changes the geometry of the movement significantly, you shouldn't use it. So it's got to be light enough to where it adds resistance, overloading you, but not too much. Next thing I'm going to talk about is frequency and workout distribution. So Hakkinen did a study where they took high-level elite weightlifters and they followed them for 6 weeks of their training. And they had them do one session a day. And this strength before and after, there were no gains in strength. That's not surprising because these were elite athletes. They then took that same training volume, say they're doing 10 sets of bench press, and they divide it into morning and night. So they did 5 in the morning, 5 at night. And look what happened. They made big-time gains in strength and hypertrophy. So why is this the case? Well, one, the quality of the workout is better. 2, just like learning cognitive skills, would you be better off studying a little bit in the morning, a little bit at night, or stuffing all your studying at night? It's better to distribute your actual studies out. And the same thing is, anytime you're practicing a skill, and it's a skill to recruit motor units, then you're going to want to distribute that practice out. And in fact, there's studies out of Norway that show that instead of training 3 days a week, splitting that same training volume into 6 days a week, you result in greater gains. Exercise order is a sequence of resistance exercise performed during one training session. So in general, if you perform a structural or compound movement first, before an isolation, that's better. Because if you look at here, what they do here is they're looking at the compound movement here and the force output from set 1 through 4. This is normal, and then they perform the isolation after. In session B, they perform the isolation exercise first, and then the compound after. Notice when you perform the compound movement first, it impairs force dramatically. So order these exercises. Which one would you do first? If you said that was 1 squat and that was 2, you'd be correct. And now you have 2 compound movements in isolation. How would you order these? You'd be right if you said that number 2, that number 3. Unfortunately, we have a lot of guys doing this as number 1. So why 2 compound movements? Why'd you select the squat before bench? 1 is because it takes more skill, and 2 is because it takes more physical exertion, and more central drive. So if you, for example, had a squat and a leg press, what would you pick first? The squat, right? So it's what more physically demanding, and of course, what activates more tissue. Now, load and repetitions, this percentage of 1 RM, it makes sense. If you're 100% of your 1 RM, you get 1 rep. If you're at 65% of your RM, you get 15 reps. The point is that the heavier you go, the lower the repetition range is. So we like to define repetition ranges based on rep range till failure or percentage of 1 RM. So now we're talking about power, and you're talking about repetition range. This is a good study by Baker. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 reps. Look at what happens to power. Reps 1, 2, 3, 4, 5. So basically, based on this, then power starts to drop off. Because you're trying to optimize the quality of a session during a power session, you're going to select a 1 to 5 repetition range. And again, it's going to be a 40 to 60% of your 1 RM. As far as for hypertrophy, this is looking at protein synthesis in young and elderly, and notice that protein synthesis peaks at around 60 to 75% of your 1 RM. So basically, you're going to use short rest periods, moderate intensity, like 60 to 75%, and 8 to 12 reps. As far as strength is concerned, strength is all about learning to recruit the larger motor units. That's 50% of your 1 RM, and that's the small motor units. 75% of your 1 RM, that's moderate motor units, and that's the large motor units. This is why we think basically you need to train at greater than 85% of your 1 RM for 1 to 5 reps to optimize motor unit recruitment and neural adaptations. So we see here for strength, 1 to 5 reps, power, 1 to 5 reps, hypertrophy, 8 to 12 reps. Anything past this is muscular endurance. As far as rest period lengths, in this study here, they rested 30 to 60 seconds versus 3 minutes on the squat. Notice you got greater gains when you squat it with 3 minutes rest versus 30 to 60. So for hypertrophy, you're not going to optimize strength. You'll get stronger, but you won't optimize strength. But when you rest longer, you optimize neural adaptations. So again, you should probably rest 3 to 5 minutes for strength. For hypertrophy, remember this study by Kramer, 1 minute rest results in the greatest anabolic response when combined with 10 reps as compared to 1 minute rest with 5 RM or 3 minute rest with 10 RM. So again, you got to have the repetitions right, but you can only be resting 60 to 90 seconds. So for strength and power, 2 to 5 minutes, 2 being power. Hypertrophy, 30 to 60 seconds, no more than 90. Endurance, less than or equal to 30 seconds. As far as volume, we can compare single versus multiple sets. And ideally, multiple sets are going to be better than single. These are each individual studies looking at strength. You see that multiple is always better than single in general. So multiple sets. How many sets is that? We currently don't know. But we know that 3 is better than 1 in untrained and novice. We know that 8, for example, is better than 3 in highly trained. So summary for hypertrophy, 8 to 12 reps, 30 to 60 seconds rest, multiple sets, compound and isolation movements. Strength is 1 to 5 repetitions, 3 to 5 minutes rest, multiple sets, compound movements. Endurance is greater than 13 reps, less than 30 seconds rest. Multiple sets could be compound or isolation depending on the endurance goal. And power is 40 to 60% 1 RM, 1 to 5 reps, 3 to 5 minutes rest, multiple sets, and compound movements. Thank you, and check out those questions on Blackboard, and I'll see you in class.